seen as a complex subject, is a powerful tool in the finance industry, helping professionals navigate through various financial decisions. Let's explore how concepts like derivatives, integrals, and differential equations come into play, and I'll share these insights in a way that could be easily followed. So first, we have derivatives, understanding changes and market and managing risk. So imagine I'm running my own small business selling handmade crafts. One day, I noticed that the cost of materials like fabric and paint changes daily. So to stay ahead, I need to understand how these costs might change tomorrow based on today's price. And this is where the concept of derivatives comes in. So think of a derivative as a way to measure how fast something is changing. For example, if the price of fabric increases by 500 Vietnam dong each day, I can say that the rate of change, or derivative, is 500 Vietnam dong per day. And this simple calculation helps me predict tomorrow's price and plan my purchases accordingly, ensuring that I don't overspend. In finance, this concept is crucial. Imagine I'm dealing with stock prices instead of fabric, and by understanding the rate at which a stock's price changes, I can make better investment decisions, avoiding sudden losses and capitalizing on gains. So we can conclude that derivatives is how something changes over time. Over time. So now let's talk about integrals. If derivatives helps us understand how things changes, integrals help us add up those changes over time. For instance, suppose I'm saving money to expand my craft business. Every week I set aside 20,000 Vietnam dong. After 4 weeks, I want to know how much I've saved. And instead of adding 20,000 Vietnam dong 4 times, I can use the concept of integrals to think of it as accumulating my savings over time. And after 4 weeks, I'll have saved 80,000 Vietnam dong. And in the financial world, integrals are used in a similar way, in a similar pattern. So let's say a company earns 1 million Vietnam dong in profit each month. And to find out how much the company earns in 1 year, I can think of it as adding up the monthly profits over 12 months. This total, or integral, helps the company understand its overall financial health and plan for the future. And now we come to differential equations. So they might sound complicated, but they are essentially equations that help predict how things will change over time. Let's say I'm cycling down a hill and I want to know how my speed will change as I go further down the hill. A differential equation can help me figure out that out based on how steep the hill is. So in finance, differential equations are used to predict trends like interest rates or stock prices. For instance, if the interest rate on my savings accounts changes depending on how much money I have saved, a differential equation can help me predict what the interest rate will be in the future, helping me decide when to save or when to spend. Now let's solve a math problems on probability. So two sealed envelopes are presented, each containing a different amount of money. One envelope contains twice as much as the other. A person chooses one envelope at random and opens it, revealing a sum of money. They are then asked if they would like to switch to the other envelope. So let's suppose that this person is me. I'll have my marker here. So we come to the first step, facts, ideas, collection. I'm presented with two sealed envelopes. One contains a certain sum of money and the other contains twice that amount. I randomly pick one envelope, open it, see the amount of money inside. Now I have the option to switch to the other envelope. And the key question here is, should I switch the envelope or should I just stick with the initial one that I chooses? So I choose. So this is where I move to the second step. The second step, data handling. So to handle the data, I start by defining the amount of money in the envelope. I chose it as X. So now the other envelope must either contain 2x if it's the small amount, or x by 2 if x is the larger amount. Because I have no prior information on which envelope is which, I consider both possibilities equally likely, meaning there's a 50-50% chance that I'm holding the smaller envelope or the envelope with the larger amount. So we next look at planning. I need to calculate the expected value of the money in the other envelope if I were to switch. This involves considering both possible outcomes, finding 2x or x by 2, and their associated probabilities. The plan is to compare this expected value to the amount of money in the envelope. I initially choose x. So if the expected value is AV is greater than x, then switching is the better choice. And here's how I strategize. If the other envelope contains 2x, then I would gain x. But if the other envelope contains x by 2, the loss of it would be x by 2. So since each scenario is equally likely, 50% chance, I calculate the expected value of switching. First, in words, the expected value equals the probability of the good outcome times the amount earned in the good outcome altogether plus the probability of the bad outcome times amount earned in bad outcome. Plus x altogether plus b plus x of b. Okay, so that's how I strategize. So the expected value equals 0.5 plus 2x. Altogether we times it by 0.5 plus x by 2. So here it equals x plus x by 4 equals 5x by 4, which is greater than x. So the math here shows that the expected value of switching is 5x by 4, which is higher than the value x that I currently hold. So this suggests that on average, I would benefit from switching envelopes. However, after switching, I would face the same decision again with a new envelope, potentially leading to an endless loop. But practically, this paradox doesn't change the fact that the math indicates switching is a better choice based on expected value, even though luck and fate serves as a factor in this too. So this is the solution. So the problem highlights how understanding probability and expected value can guide decisions, especially when outcomes are uncertain, which is critical in financial analysis. With the problem presented above, a real-world example might be deciding whether to invest in a new project with uncertain returns, just like the envelope problem. Using probability and expected value can help make informed decisions about risk and reward. So, in conclusion, we know that calculus isn't just about complex equations. It's a powerful tool that helps me make informed decisions in my business, my life. And by understanding how things change, adding up profits over time, and predicting future trends, I can navigate the financial world with confidence and a bright smile. And with a little bit of math, I can ensure that my business stays on the path to success. After all, knowing when to save or when to spend is just as crucial, as important as making those delicious crafts. Thank you.